let's go ahead and take a look at the difference quotient. So finding the difference quotient is similar to finding the slope of a line. As far as the process goes, you need to find the change of your y's over the change of your x's. But we are using function notation, and specifically our x values are going to be, one of them is going to be x, but the other one's going to be h units away. So if it's h units away, it's x plus those h units. So those are our two x values. So if we use the concept of slope to kind of help us write the formula, we know it would be a change of our y's over a change of our x's. Where our y's would be our function notation, so we would use f evaluated at our x values. So x plus h is one of our x values, and x itself is our other x value. So we would do f of x. So that'll give us our y values, and we need the difference between those, so we subtract, divided by your x values. So x plus h is one of them, and x is the other, and we want the difference, so we have to subtract those. So if we simplify that down, in the numerator we have f of x plus h minus f of x all over, the x's will cancel in the denominator and you're left only with h. And so that is your difference quotient. Now let's go ahead and take a look at a specific example where our f of x is x squared minus x, and we're wanting to find the difference quotient in this particular form. So if we're trying to find the difference quotient, we need our three pieces of the difference quotient, which are f of x plus h, f of x itself, and h. And then ultimately we're going to plug that into the difference quotient formula, which is f of x plus h minus f of x over h. But we have to get those three given pieces first. So for f of x, that is a given. F of x is defined as x squared minus x, so there's no work to be done there. And the same thing goes for h. They don't tell you what h is, so h is just h, so you can just kind of say h again. But f of x plus h, we could actually determine what that is because it's our function evaluated at x plus h. Well, our function has the form x squared, but don't fill in the x, minus x. And we want to evaluate at x plus h. So what we would do is wherever there was an x, we would put x plus h. And as long as we have our parentheses in place, that'll help us do this appropriately. And then we just need to simplify that down. Notice whenever you're squaring, that is a foiling problem. So if it helps you, x plus h squared is x plus h times x plus h. So maybe list that out so you can see that you need to FOIL. And then we will need to subtract off x plus h, which I'll go ahead and do by distributing that negative. So subtract x and minus h. So now I'm going to go ahead and FOIL first. X times x is x squared. Outside would have been xh. Inside is also xh or hx, but that's the same thing, so just put it in the same order, you might as well. And then last is h times h, which is h squared. And then minus your x minus h. Simplify by combining like terms. X squared plus 2xh plus h squared minus x minus h. So then now what we can do is we can go to our formula and we can plug in what we have. So for the numerator piece, the first piece here is f of x plus h. Well, we know what that is. We just found it. So I'm just going to rewrite it again. It's x squared plus 2xh plus h squared minus x minus h. And then I'm to subtract off my f of x piece, but my f of x piece is x squared minus x. And then in the denominator I have h. So if we go to simplify further, notice x squared minus x squared will cancel. You still have the 2xh piece. You have the h squared piece. This has a minus x, but this has a minus a negative x, which will be plus x. So those x's will cancel. And so you just have the minus h all over h. But notice every term has h in it, in the numerator and in the denominator, so we can go ahead and divide out h from each term. And so we're left with 2x plus h minus 1 all over 1, but you don't need to write that. And so this is your difference quotient. The difference quotient appears to be linear because it's mx plus some constant h minus 1. So the difference quotient is 2x plus h minus 1. Now let's go ahead and take a look at the difference quotient, but in a different form. So we're going to use the form f of x minus f of a over x minus a. So in other words, your x values are going to be like a general x value and a specific value, call it a. And so again, the concept still is that you're doing slope, right? So you're going to take your function evaluated at that general x value, take your function evaluated at that specific a value, which is an x value, but it's a, and take the difference, and that's the change of your y's, over the change of your x's, but your x's were x and a, so you need the difference of those. And so that is also a difference quotient. Notice that x is not allowed to be a itself, because if it were, then you would get division by 0 in the denominator, and you cannot do that. So now, if we want to go more specifically, we can work on solving a specific problem. So again, you want to kind of identify your pieces of your formula first. So you need to figure out who is your f of x, who is your f of a, x, and a. And then once you have all of those pieces, then you can kind of plug into your formula f of x minus f of a over x minus a. And again, x is not allowed to be a itself. Well, f of x is given. It's 4 over x. And f of a is just your function f of x, but don't write x, replace it with a. But we know that a is a specific value. A is 1. So replace a with 1. So 4 divided by 1 is just 4. So f of a is 4. X is just that. Nothing was given for x, so x is x. It's a general x. And then a is specifically 1. So I now have all of my pieces that I need, and so I just need to plug them into my formula. So I'm going to plug in f of x first. It's 4 over x. And then I'm supposed to subtract and then plug in my second piece, which is f of a, which ended up being 4. And I'm going to write it as 4 over 1 since I have a fraction already. All divided by x, which x is just x. Nothing was given for x. It's a general x. Minus, put your minus, the a piece, but they tell you that the a piece is 1. So in the numerator we need a common denominator, so I'm going to have to multiply my second fraction there by x in the denominator as well as the numerator to get that common factor of x. And so if I do that, I have 4 minus 4x divided by the common denominator of x, all over x minus 1. But you have a fraction divided by another fraction, so if it helps you, rewrite that so it says that. So it's 4 minus 4x over x divided by x minus 1. And I'm going to write that over 1 so you can see the fractions. But the way you divide fractions is you multiply by the reciprocal. So this is 4 minus 4x over x times the reciprocal of that second fraction, which is 1 over x minus 1. And then with multiplication, you usually look for canceling. And it may not be obvious, but this first term here has a factor of 4 in common. So I'm going to rewrite where I factor out that 4. And so if I do that, I'm left with 1 minus x over x times 1 over x minus 1. But there's nothing identical to cancel right now, but these look like they're opposites. Like if basically I factored out a negative, they would end up being the same. And so I'm going to actually factor out a negative as well, so a negative 1. And so this becomes negative 4 when I pull out that negative 1. And then these signs change, so this goes minus 1 plus x. But I'm going to change the order of that at the same time. And then that way you can see that in the numerator and a denominator here we have a common factor that can cancel. And so we're left with negative 4 over x as our difference quotient.